Alright, so today we're going to study exercise 10F, sum and product of zeros of the polynomials. Okay, we're just going to start with a formula. Okay, firstly, if you look at the zeros, which is the root of the polynomial equations, the root itself has a relationship with the coefficient of the polynomials. Okay, not really sure if you actually noticed that or not, but there is a relationship there. So we, I'll prove that for you later, but I'm just going to write down the first one, sum and the product of zero over quadratics. So for example, if we have a quadratic equation, okay, and then if we know the roots are alpha and beta, so we've got two roots, alpha and beta, the sum of the two roots is equal to negative b over a. The product of the roots is equal to c over a. Now, what's a and b and c? Well, if you look at the quadratics, we are actually looking at this quadratic equation with a general formula, like ax squared plus bx plus c is equal to 0. So what does that tell you? It tells you that the coefficient, if you look at the coefficient, that's a, that's b, and that's c, which is the constant number. Those constant numbers now are actually in here. Okay, which means that the coefficient of the quadratic equation has some sort of like relationship with the root alpha and beta of the quadratic equation. All right. Now I'm just going to use one example, a simple example, to actually at least to show you that that works, and then I'm going to prove that for you. And then later we're going to move on to not just the quadratics. We're going to find the sum or product of zeros of a polynomial, especially if it's a cubic and a quartic polynomials. All right, so start with a very simple example, something that we can solve, like everybody know how to solve for quadratics. So let's just start with an example 1. For example, if we have a very simple quadratics, x squared plus 6x plus 5 is equal to 0. That's quadratic, right? And if you want to solve this quadratics, we just need to factorize it. That gives us x plus 1, x plus 5. Is equal to 0. So therefore, the answer we have is x equal to negative 1 and x equals to minus 5. Okay? Now, based on this information here from the previous relationship, we know the sum of the two roots right now is equal to minus b on a. Okay? So how do I do that? How do I really show that's actually true? So let's rewrite this formula here. Okay? All right, and then let's write down a 1 in the front here as well. I just want to identify that what's A, B, and C. So from here, we know 1 is just the A, the 6 is the B, and 5 is the C. Okay, all right. So now what we can do is we actually can find the sum of the roots, okay, is equal to x1, let's just say x1, x2, or alpha, beta, doesn't matter which one you want to use, x1 plus x2, and that is equal to minus 6, okay? And then we do the product of the root. All right, the product of root is x1 times by x2, and that is equal to, what is that equals to? That is equal to 5. That's the product of the root. All right, now once we actually finish that, then we can actually look at the actual formula. The sum of the roots is minus b on a. So if we just write down minus b on a, and then we try to get information from here, minus b, okay, b is equal to 6 on a, which is 1, so that's equal to negative 6, which now, as you can see, they are equal to each other. And then the product of the root is c on a, which is equal to 5 on 1, and that is equal to 5 as well, okay? Now, this formula works no matter if the leading coefficient is equal to 1 or not, okay? If the leading coefficient is not equal to 1, the formula also works as well, okay? So this, it's regardless of the what is the coefficient in the front. All right, so the question here is, why it is useful and why this works, right? And how come this relationship between the solution of the equation with the coefficient of the equation? All right, so in order for me to actually prove this, we sort of need to start from the very beginning. So let's just start to do the proof. We start with a very beginning part, okay? So we know for any quadratics, if we have two roots, so if we note if alpha and beta are the roots, from the last lesson that if they are the roots, then therefore x minus alpha and x minus beta will be the factors of these polynomials, or in this case the quadratics, and that is equal to 0. okay, if that's the root. So if they're the roots, I'm just going to move this one over here. Okay, so if they are, alpha and beta are the roots of this equation, as you can see, that's a quadratic equation, ax squared plus bx plus c is equal to 0. Then in that case, what we can also write is, if we know these two are the roots, we can write down two factors like that, okay, which is x minus alpha and x minus beta. I can put a in the front, but in this case, it doesn't really matter here. And then this is the equation we have here. Obviously, these two equations should be identical to each other. They should be equal to each other. Of course, if they're not equal to each other, then it's we can't write down alpha and beta in terms of like an x minus alpha, x minus beta. So therefore, if they are equal to each other, what we can do is we can make them equal. So like we can expand the left hand side first. All right, so expand that part first. We're gonna get x squared minus x beta minus x alpha plus alpha beta. All right, is equal to 0. So if we factorize, we are going to get alpha plus beta inside, and that's x plus alpha beta is equal to 0. Now on this side here, we end up with like ax squared plus bx plus c is equal to 0. I can divide everything by a, since a is not equal to 0. So I can divide by a, that gives us x squared plus b over a, x plus c over a is equal to 0. Okay, so once we finish that, since we know they're equivalent to each other, what we can do now is equating the coefficients. So look at the coefficient in front of the x. That's the coefficient in front of x, and that is the coefficient in front of x. So that tells you that, that coefficient must be equal to each other. Now look at the coefficient in front of, look at the constant number. That is the constant number, that is the constant number. So now, if we rewrite it, we're going to get negative alpha plus beta is equal to b on a. So therefore, alpha plus beta is equal to minus b on a. And then the constant number, if you equal them together, alpha beta is equal to c on a. And that's it. That's the formula we have. So now we have the sum of the roots and the product of the roots. Okay, all right. Now I'm going to show you the application a bit later, like what sort of question we are going to see later on. But right now, what I need to do is move on this from the sum of the products, sum and product of zeros of quadratics to cubic, and then eventually to the power 4. Okay, so if you just follow the same idea, we can generate another another set of formulas for sum and product of zeros of a cube, all right, of a cubic. So what does that mean? Okay, so if we let p of x is equal to like ax to the power 3, a cubic polynomials, plus bx squared plus cx plus d, and then we know that this equation, all right, have zeros, alpha, beta, and gamma. All right, then in that case, we can have those formula. The sum of those roots, alpha plus beta plus gamma, is equal to minus b on a, which as you can see is the same as the first one, minus b on a. And then that's the sum of the zeros. Then the next one is not really the product of the zeros. It's actually the sum of the product of pairs of zeros. So we're going to do 2 at a time. So we're going to combine alpha and beta together, and then alpha and gamma, and beta and gamma. So it's going to be like alpha beta plus alpha gamma plus beta gamma is equal to c on a. So this is still the sum of the product of pairs, okay? All right, and the last one is obviously the product, all right? So it's alpha times by beta times by gamma, and that's equal to minus d on a. And that becomes the product of the zeros. All right, so those are the formulas. That again, you need to memorize those formulas. It's not on the formula sheet. Now, the question here is how do we memorize the formula? If you look at this, it's actually pretty easy. We start with B and C and D. They're all divided by A, Okay, so the first one is the sum, and then you have the sum of the two terms, and then you've got just the three terms, when they times together. So the way to remember the formula is also, if you remember this is the correct order here, then you're going to use the B over A, then use C over A, then use D over A. How do I know which one's negative or positive? All right, it's in this fashion. It's negative, positive, negative, positive, negative, positive. Now the reason I'm writing the rest of those ones here is because when we're actually doing something like to the power 4, you're gonna have another set of formula here, which that gives it negative, positive, negative, positive. All right, so that will be like a positive E on A. Okay, so this is the sum and the product zeros of a cubic. Now, the proof is the same, okay, so I'm not going to show you the proof here. The proof is very similar to the proof with the quadratic. All right, so the next one I would like to write it down is the sum and the product of zeros of a quartic, so it's power 4. Alright, so if it's a power 4, what would the formula? You can have a guess what's the formula going to look like, okay? So if we have like, P of x is equal to a power 4 in our expression here, so ax to the power 4 plus bx to the power 3 plus cx to the power 2 plus dx plus e have those roots alpha, okay, have zeros of have zeros alpha, beta, gamma, and delta. Okay, so in our case here we've got 4 roots, as you can see here, 1, 2, 3, 4, because the highest power is equal to 4. So obviously the maximum number of solution is 4 solutions there. Okay, so with this one here, then how do we write down this, the formula here? Now I'm just going to show you without looking at this. I'm going to show you the first one is always the sum of the zeros, which means you just plus all the roots together, and it's always equals to minus b on a. All right, so that's just the sum of the roots, or sum of the zeros. The next one, okay, is always the sum of the product of a pair, okay? It's only one pair, so the product of the pair. So in that case here, it will be alpha, beta. Now this time it's going to be a bit tricky, okay? So this time is going to be like, alpha, beta, and you're going to do alpha, beta, alpha, gamma, alpha, delta, and then beta, gamma, beta, delta, and the last one is gamma, delta. If you don't have the systematic approach of this, like about writing the product of the two terms together, you will miss the term, okay? So please do it this way. So alpha, beta, alpha, gamma, alpha, delta, and then you move on to beta, gamma, beta, delta, and the last one is gamma, delta. So you should have 1, 2, 3, 4, 5, 6 terms. All right, so keep in mind you should have 6 terms. If you don't, something's not right. The next one is, since we have already used a B, now we're going to use a C, and since this is already a minus, this is going to be a plus. Okay, so plus C over A. This is the sum of the sum of the product. All right, the sum of the product of pairs. Okay, of roots. All right, then what will be the next one? Well, since we have the sum of the products, okay, of pairs of zeros, or pairs of roots, now we can have the sum of product of triples of zeros. So we're going to use 3 terms at a time. Okay, so like alpha, beta, gamma, so 3 terms at a time, and then you do alpha, beta, delta, and then you keep going that way. Again, you need to develop your own system of writing it, otherwise it's really simple to make a mistake. I'll just do alpha, beta, okay, gamma, alpha, beta, delta. Okay, once I finish that, and then move on to the beta, gamma, delta. Okay, and then you should have the last one, which is gamma, delta, and alpha. Okay, I would suggest you to actually check out each of the terms here. Make sure there's no doubles. That you didn't do like terms. You didn't just simply switch those letters around to create another terms. Okay, so that you should only have 4 terms there, and then it's going to be if you look at it, that's B, C, so it will be a D here. That's minus, plus, and that's going to be a minus. So minus D on A. Okay, so sum of the product of not, pairs, but this time triples of zeros of roots. All right. The final one, the last one, is the product of all the roots together, which is the alpha, beta, gamma, delta, and that's E on A. Okay, and that's just the product of the roots. All right, now this is to the power 4. Am I going to do power 5, power 6? No. Okay. You don't need to worry about power 5 and 6 and 7 and goes on. Okay, the maximum is going to be up to is power 4. It's going to be crazy enough. The application type of question, if it's power 4, it's going to be pretty, algebra demanding. So you need to have a very good algebra skills, be able to manipulate those algebra expression around to actually do certain questions. That's basically for the sum and product of the roots. That's all the concept that you understand. Now it's basically like, how do we use those concepts? How do we use all of those formulas to actually do the questions? I'm going to break down this lesson into 2 parts. So for the first part here, it's all about just the concept, developing the formula, alpha, beta, gamma, delta. Then in the next lesson, I'm just going to purely try the questions. There are so many different type of questions there, so that's why I need to break down into 2 parts. Otherwise, it'll take a long time for this lesson to finish. Okay, so I'll finish up to now, and please, if you want to prove the formula for the next one, you can. Okay, just remember this. If you want to prove those formula here to see if that's true or not, you need to have those x minus alpha, x minus beta, x minus gamma is equal to 0, and you need to expand this expression and then equating the coefficient here, and you should be able to get each of the terms there. The proof is not required. All right, eventually you just need to know the formula and be able to use the formula to actually do the question. All right, so that's all for this lesson. All right, please make sure that you watch the second part of this lesson here for the example questions. All right, thank you.